Hi everyone, welcome to this week's lesson for junior cycle higher level. So this week we're going to be focusing on Pythagoras' theorem and different questions associated with that, parallelograms and also circles. So as usual we're going to be going through some theory and then we'll go to some exam questions and their solutions. Okay, so the first thing that you see on the screen there is Pythagoras' theorem. So Pythagoras' theorem, I'm going to just write it up on the corner here. When we have a right-angled triangle, which means that we have one right angle, so this is going to be the hypotenuse, and I'm going to name this the opposite and this the adjacent. So the rule for Pythagoras is the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So remember that a right angle is 90 degrees, so it's 90-degree angle. We denote right angles in the diagram like this. So you can see it like this in the diagram, like that, or the way I have it done up here. So either of those symbols mean that it's a right angle, and a right angle is 90 degrees. So a right angle triangle is a triangle in which one angle is a right angle. So then we're going to go to our first example. So it asks us to find the measure of the unknown angle in the following triangle. So it's given us one angle, it's 40 degrees. This symbol here is for right angle, which means that this must be 90 degrees. And we're being asked to get the unknown angle, which is this angle here. I'm going to call this angle X. Now we know that there are 180 degrees in total in the triangle. Now the solution is done below, but I'm going to do it out along the side as well, so I can talk through it as I'm going through the answer. So we know that 180 degrees are in a triangle. So if we were to add up all of the angles there in the triangle, it would be 90 degrees plus 40 degrees plus x would give us 180 degrees. So if we add 90 plus 90 plus 40, we get 130. Plus x is equal to 180 degrees. So x is going to be 180. We bring the 130 over, so it becomes minus 130. So x is going to be 50 degrees, which is the answer given below. So the key thing is to remember there, and I'm going to make note of it here. So there are 180 degrees in a triangle. Okay, so we're going to go on to the next example now. In a right angle triangle, we already know how the angles are related. So how are the sides of a right angle triangle related? So the following theorem answers this question, and I've just gone through it above. So Pythagoras' theorem, if C is the length of the side opposite the right angle, which is known as the hypotenuse, so I'm just going to mark that into the diagram, it's the hypotenuse, then A and B are the lengths of the other two sides. Then the rule is C squared is equal to A squared plus B squared. So another way of writing that is the hypotenuse squared is equal to the opposite squared plus the adjacent squared, and that is given to you in your log tables. But you have now it's given, the rule is given to you, but you have to know how to apply it. So that's Pythagoras' theorem. So this theorem applies to any right angled triangle, and here are some examples. So the example there, what is the value of C in the following diagram? So they're given us one side of 3, another side of 4, and the missing side, which is C. Now C is opposite the right angle, as you can see. So C is the hypotenuse. Now because we don't actually have an angle in that diagram, it doesn't matter which way you label the opposite and adjacent. So I'm just going to say that this is the opposite and this is the adjacent. So the rule is hypotenuse squared is equal to the opposite squared plus adjacent squared. In this case, our hypotenuse is C, so it's going to be C squared is equal to O squared, which is 4 squared, plus A squared, which is 3 squared. So C squared is equal to 16 plus 9. So C squared is equal to 25. So remember, when we want to get the inverse, we'll say, of the square, we get the square root on the other side. So C is going to be the root of 25. The root of 25 is 5. So C is 5, which is the value that they've given. Okay, so the next example, what is the value of x in the following diagram? So again, we have the hypotenuse, which is opposite the right angle here, so that's the hypotenuse. We'll say that this is the adjacent, and we say that this is the opposite. So it doesn't matter which way you label it when you don't have an angle, okay? So again, our rule, the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So the hypotenuse is 7 squared is equal to the opposite squared, which is 5. So 5 squared plus the adjacent squared in this case is x squared. 7 squared is 49 is equal to 5 squared, which is 25, plus x squared. So we're going to get numbers on one side, letters on the other. So 49 take away 25 is going to give us x squared. 49 take away 25 is 24. So 24 is x squared. So x is going to be the root of 24, and that's what they've left it as. So that's that one done. Another example here. So a ladder is 13 feet long. When the top of the ladder is resting against the top of a wall, the bottom of the ladder is 5 feet from the wall. How high is the wall? So you can see there in the diagram, we have 13, which is obviously going to be our hypotenuse because it's opposite the right angle. So this is our hypotenuse. Again, we're not given an angle, so it doesn't matter which way you label the others. So we'll say that this is the opposite, and we'll say 5 is the adjacent. So the rule is the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So that's 13 squared is equal to the opposite squared, which is h in this case, so it's h. So h squared plus adjacent squared, which is 5 squared. 13 squared is 169 is equal to h squared plus 25. So again, same idea, you want to bring numbers to one side, letters to another. So 169 take away 25 will give us h squared. 169 minus 25 is 144. So h squared is equal to 144. We want what h is, not what h squared is. So h is the root of 144. H is 12. And that's the answer they've given below. So I've just done it out there. So the wall is 12 feet high. And the reason it's saying that it's 12 feet high is because we were told that the ladder was 13 feet long, and then the ladder is 5 feet from the wall. So it's given to you in feet, so your answer will be in feet as well. Okay, we're on to parallelograms now. So a parallelogram is a quadrilateral. So a quadrilateral is a shape that has 4 sides, A, B, C, D, with the property that AB is parallel to CD. So that sign there means parallel, and that's really important that you know that. So AB is parallel to CD. So I'm just going to mark these into the diagram. So AB is parallel to CD, and then the side BC is parallel to AD. So BC is parallel to AD. So we know parallel lines are lines that are never going to meet, so they continue on. So if we extend the sides of this parallelogram, we can observe that the marked angles A and B are equal because they are corresponding angles. So you can see here the angle A and the angle B, they're corresponding angles, so they're equal. These two angles are equal. Now another thing, the angles at B and C, they're also equal because they are alternative angles. Okay, and there's a lesson on transversals on that. So this angle C is also equal to the angle B, and the reason is because they are alternative angles. And then also the angle DAB, which is this angle here. So this is the angle DAB. You always look at the angle in the middle, plus the angle ABC. So the angle ABC. So the angle ABC is going to be this angle here. So the angle ABC is equal to 180 degrees. And the reason for that is because it's a straight angle. Okay, we're going to go on for another example for a parallelogram. So if the parallelogram PQ or S has the angle SPQ, which is 70, so you can see that here in the diagram, what is the measure of the other angles? Now, there's a rule for parallelograms, and the rule is, and it's based on a theorem, is that opposite angles in a parallelogram are equal. So I'm going to write that down. So opposite angles in a parallelogram are equal. So based on that rule, if we look at the angle P is opposite the angle R, so that must mean that this angle here is also 70 degrees. Now the other thing I want to write down here is that there are 360 degrees in a parallelogram. So there are 360 degrees in a parallelogram, and I'll just show you in a minute how you can prove that. If you were to bisect, so I'm just going to draw a line here. If you were to bisect that parallelogram, you have two triangles. You have this triangle and you have this triangle. There's 180 degrees in one triangle and there's 180 degrees in another triangle, which means there's 360 in total. Now, we have just said that the rule, so the opposite angles in a parallelogram are equal. So that we've dealt with the angle P and R. Now we'll deal with the angle Q and S. Both of those are equal as well. So the angle Q is equal to the angle S. Now, we've dealt with the 70 degrees and 70 degrees, so that's 140 degrees. So to get what's left is going to be 360 degrees minus 140 degrees. And that will give us 220, so 220 degrees. So that means that there's 220 degrees left between this angle and this angle, and they're both the same. So if they're both the same, it's going to be 220 degrees divided by 2. 220 degrees divided by 2 is 110 degrees. So this angle here is 110 degrees, and this angle here is also 110 degrees. So that's the answer. The solution is here as well, and you can see it's done out there. So the angle QRS is 70 degrees since opposite angles in a parallelogram are equal. The remaining two angles must be equal to 110 degrees to ensure that the sum of all of the four angles is 70 plus 70 plus 110 plus 110 is equal to 360. So that's it done out there. Okay, so we're going on to the next section now, and then we just have right angles and semicircles, and then we're going on to some exam questions. Okay, so the angles DAB, which is this angle here, and the angle BCD, which is this angle here, so they're equal, and the reason that they're equal is because we just talked about it, that opposite angles in a parallelogram are equal. Now also the angle DBC, so the angle DBC is this angle here, and the angle BDA, which is this angle here, they are also equal because they are alternate angles of a transversal. So that means that the remaining angles must also be equal. So I'm just going to highlight them. So this angle must be equal to this angle. So the triangles ABO, so that's the first triangle, and the angle CBD are similar. In fact, since they have a common side BD, they are congruent triangles, so the same angles and side lengths. So this triangle here should be the triangle ABD. So the triangle ABD and CBD. So this means, so the last sentence here, that the side AB, which is, I'm going to highlight it here, so this side here, the side AB is equal to the side CD, and then also the side AD, which is this, is equal to the side BC. So from that then we can say that opposite sides of a parallelogram also have equal length. So that's important to note as well. Okay, we're on to right angles and semicircles. So we're on to the first corollary there, so corollary 3. So a corollary is a rule that's already been proved. So what it says there is if BC is a diameter of the circle. Now I'm going to just show you the diameter here. So the diameter BC, so if I drew a line connecting up B and C, that's the diameter of the circle. What they're saying is then A is another point on the circle, which is this point here. They're saying that the angle BAC, which is this angle here, is 90 degrees. So they're saying if you've got the diameter from B to C, and you've got another point A, then the angle BAC is equal to 90 degrees. This brings us on to our next corollary. So this kind of is the inverse of it. So if the angle BAC is 90, so they're saying if this angle is 90 degrees, then BC is the diameter of the circle. So they're saying that this is the diameter of the circle if the angle BAC is 90 degrees. So it's kind of the opposite of what we looked at before. Okay, so we're going to go on to an example now. Suppose that A, B, and C are points on a circle of radius 5. Now, what that means is the radius, so if we were to put the center of the circle, just put it here. The radius is the distance from the center of the circle to any other point. So that would mean that this distance is 5 and also this distance is 5 because that's also a radius. So they're saying that AB is the diameter of the circle and the length of BC is 6. What is the length of AC? Okay, so you can see quite clearly here that this is a right angled triangle. Okay, so there's one side, there's our second side, and there's our third side. So I'm going to just redraw this triangle. Okay, so it's going to go like this, and we know that this is a right angle, and we know that this full length is 10. Now, if this side is opposite the right angle, that must mean that this side is the hypotenuse. We know that this side is 6, and we're being asked to get this side. So we can use the theorem of Pythagoras. So we know that it's the hypotenuse squared is equal to the opposite squared plus the adjacent squared. We've labelled the hypotenuse already. I'm going to label this the opposite, and I'm going to label this the adjacent. So you're literally just putting it into the formula. So hypotenuse squared is 10 squared is equal to the opposite squared, which is 6 squared plus a squared, which is x in this case. We've labelled it, so x squared. So 100 is 10 squared is equal to 36 plus x squared. So again, we're going to bring numbers to one side, letters to another. 100 minus 36 is going to give us x squared. So x squared is equal to, so 100 take away 36 is 64. So therefore x is the root of 64. So x is 8. So x in this case is AC, so it's going to be 8. And if you scroll down, that's our answer. So AC is 8. Okay, so this brings us to our first exam question. So this is paper 2, 2012, question 12. Okay, so a homeowner wishes to replace 3 identical steps leading to her front door with a ramp. Each step is 10 centimeters high and 35 centimeters long. Find the length of the ramp and give your answer correct to 1 decimal place. Okay, so they're telling us for this step, each step is 10 centimeters high, as you can see here, and it's 35 centimeters long, as we can see here. So what we would need to do to find the distance or the length of the ramp, we would need to get this diagonal here. And that would give us the same as this diagonal here, which would give us the same as this diagonal here. When you get the value of the diagonal, you multiply it by 3 because you have 3 steps. So I'm going to just draw out one triangle here, which is what we have. So each step looks like this. We know that this is 10. We know that this is 35. And what we're looking for is this here. I'm going to call it x. You can see that that's a right angle there. So because of that, we can say that x is the hypotenuse. I'm going to say 35 is the opposite. And I'm going to say 10 is the adjacent. So the rule is for Pythagoras, the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Hypotenuse squared in this case is x squared is equal to the opposite squared, which is 35 squared, plus adjacent squared, which is 10 squared. So x squared is equal to, so 35 squared is 1225, and 10 squared is 100. So x squared is equal to 1325. So to get what x is, it's going to be the root of 1325. So when you put that into the calculator, that's equal to 36.4. Now, that's only for one ramp, okay? So that's only for this much here. Sorry, I'm just going to use the highlighter. So that's only for this much. We also have this ramp and we also have this ramp. You've got 3 of them. So to get the total, it's going to be 36.4 multiplied by 3. Put that into the calculator, you get 109.2 centimeters. Now, you put it to 2 or 1 decimal place, sorry, because it has asked you correct to 1 decimal place. So that's it for that question, I think. Yeah, so we're moving on to the next one. So the next one is paper 2, it's a sample paper from 2014. Okay, so this question 8, Monica has a set of 9 coloured plastic strips. So long red, a middle red and a short red, etc. as shown below. The strips can be joined together to form geometrical objects by pins through small holes at their ends. So is it possible to make an object in the shape of an isosceles triangle using any 3 of the 9 strips? Give a reason for your answer. Now, an isosceles triangle means that 2 sides are the same. So based on that, we need 2 sides of the same length. Now, if you look closely there, none of the strips have the same length. So because of that, you would not be able to make an isosceles triangle. So the answer is no. And the reason is, if we were to make an isosceles triangle, so if we were to make an isosceles triangle, we would need 2 sides, or 2 strips, we'll say, of the same length. Which we don't have. That's the answer to that one. Okay, on to the second part. Monica would like to join 4 strips together to form the shape of a parallelogram. Explain why it is not possible to do this. Okay, so in a parallelogram, we know that opposite sides have equal length. Now again, none of the strips have the same length and we're only able to pick 4 strips. So because of that, a parallelogram is impossible to make. So we're going to write down there, so in a parallelogram, opposite sides have the same length. So opposite sides have the same length. So none of the strips have the same length. So none of the strips have the same length. So therefore, we cannot make a parallelogram. Okay, so that's part 2. For part 3, the long yellow, long blue and short red strips are used to form an object in the shape of a triangle. Monica thinks that this might be a right-angled triangle. Investigate if she is correct. Okay, so the long yellow strip, first of all, is 25 centimeters. So the long yellow strip is 25 centimeters. The long blue strip has 24 centimeters. So the long blue strip has 24 centimeters. And then the short red strip, so the short red strip has 7 centimeters. So that's all given to you. Now, if this is to be a right angle triangle, it must satisfy Pythagoras' theorem. So Pythagoras' theorem is, again, the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Now, the hypotenuse is always the longest side of a triangle. So if I was to draw a sketch of it, I'll draw it here. I'm going to draw a long hypotenuse there, and I'm going to say, so the hypotenuse would have to be 25 because it's the biggest, so 25. And it doesn't matter which order you put these in, but in this case now, this would be the 24 and this would be the 7 for obvious reasons. So we need to test, does it actually equal? So h squared is equal to O squared plus A squared. So the hypotenuse squared in this case is 25 squared is equal to the opposite squared. So we'll call this H, we'll call this O, and we'll call this A. So O squared is going to be 24 squared plus A squared, which is 7 squared. So we want to see, does the right side actually equal the left side? So 25 squared, so put that into the calculator, is 625, is equal to, so 24 squared is 576 plus 49. Now what you're going to do next is add 576 plus 49 and see, does it give you 625? It does. So that means that, so I'm going to put therefore, it is a right-angled triangle. So it is a right-angled triangle. Okay, so we're on to part 4 now. This is the last part. So Monica uses the long blue and long white strips to form the angles of a right angle. Find the length of the strip that would be needed to complete this triangular shape and give your answer correct to 2 decimal places. Okay, so the long blue strip has length 24. So we got that from before. So the blue strip is 24 centimeters. The long white strip, so I'm going to just have to go up and just check what that is. So the long white strip is 20 centimeters. So 20 centimeters. And what we're being asked is what will the third side have to equal? So if these are to be the length of the two sides of a right angled triangle, then the third side must be the hypotenuse. So it's going to look like this. So we'll say this is 20, this is 24. So 24, 20, and we'll call this the hypotenuse, h. Okay, so we're looking to see what h must be. So the rule is the hypotenuse squared is equal to the opposite squared plus the adjacent squared. In this case, hypotenuse squared is equal to, say this is the opposite and this is the adjacent, and then your hypotenuse is h. So O squared is 20 squared plus adjacent squared, which is 24 squared. So h squared is equal to, so 20 squared is 400, 24 squared is 576. So add those together to get h squared, you get 976. So h is going to be the root of 976. Now look at the question, it asked to 2 decimal places. So the root of 976, correct to 2 decimal places, put it into your calculator, is 31.24 centimeters. Okay, so make sure that when it's asking for 2 or 3 decimal places or whatever it is, that you actually you correct that to the amount of decimal places that they're asking for. If you don't do that, you will get dock marks, especially when it is asked specifically for it. Okay, so I'm going to attach some extra links and video tutorials for this lesson. I recommend that you go and look at them. I'll attach it to the chat, and I will speak to you next week.